Good morning, dear students. Welcome back to the virtual class. So, in today's class, we are discussing a topic called quadratic function. So, in the last class, you all know that we have discussed regarding the linear function. So, today we are focusing on the quadratic function. So, let us start the session. Okay. So, here quadratic function means it is a polynomial function of degree 2. Okay, and can be written in the general form as fx is equal to ax square plus bx plus c is equal to 0, the standard format of quadratic equation what we have learned already. So that is the same format we are following here also. So here a, b and c are represented real numbers where a is not equal to 0. So quadratic function is a polynomial function of degree 2, and the standard format is as usual, that is ax square plus bx plus c is equal to 0. Okay, that is termed as a quadratic function where abc represent the real number and a is not equal to 0. Okay, so here graphical representation of quadratic function. Okay, so here squaring function. So here we are considering it as uh, fx is equal to x square, um, 2fx is equal to x square. So this is how we're going to graphically represent the quadratic equation. So you see here we have a graph. See this parabola is so if you are representing through a parabola, that is termed as a quadratic function. Quadratic function is a parabola. It is the general curved shape is of parabola and is shared by the graphs of all the quadratic functions. See here you have to note that graph is indeed a function and it is possess the vertical line test. Okay, furthermore the domain of this functions consists of the set of all real numbers. Okay, that is from negative infinity to positive infinity. Okay, and the range consisting of set of all non-negative numbers, that is 0 to infinity. So here domain consisting of all real numbers, that is from negative to positive number up to infinity, and the range consisting of non-negative numbers, that is 0 to infinite numbers. Okay, so this is, so here quadratic function, see this has to be like this, fx is equal to x square. Okay, don't write this here, it has been repeated twice. Okay, that's it. So fx is equal to x square. So in that format we're going to represent the quadratic function. So when we are looking at the next one, see there are certain important things when it comes to graphical representation of quadratic function. Okay, so when graphing the parabola, we want to include certain special points in the graph. Okay, so that what are the special point is the y-intercept is a point where the graph intersects the y-axis. So here you can see this is y-intercept. So here the graph is intersecting the y-axis. This is y-axis and this is x-axis, you know that. So here y-intercept is a point where graph intersects y-axis. Okay, then the x-intercept. See, x-intercepts are a point where the graph intersect x-axis. So here you can have a look on this. So here graph is touching the x-axis. This interception is termed as a x-interception. Okay. So here then we have a vertex is a point that defines the minimum or maximum of the graph. So here, so you can look at this, that is vertex. So this point is termed as a vertex. It is representing both minimum or maximum of the graph. And lastly we have a line of symmetry, also termed as axis of symmetry. So this is this line, actual dotted line what we have, that is termed as a line of symmetry, is a vertical line through the vertex about which the parabola is symmetric. So here where this at this point the parabola will going to intersect with the vertex, okay, that is termed as a line of symmetry. That particular line is termed as a line of symmetry, the dotted line. Okay, so this is with respect to the special points when regarding a graphical representation of quadratic function. Then we have certain steps to follow all these things, as we have y-intercept, x-intercept, vertex, as well as line of symmetry, that has to be calculated. Okay, if they are asking you to represent the quadratic function in a graphical format. Okay, so we'll go one by one so that you will understand the concept better. Okay, see, for any parabola we will find the vertex and y-intercept. In addition, if the x-intercept exists, okay, then we will want to determine those as well. Okay, usually x-intercept will not be there. Okay, if it is existing, we have to find the y-intercept and remaining all other special points. Okay, guessing at the x value of these special point is not practical. Okay, so here whatever value you want, you can guess that as a point, special point for a x value. Therefore we will develop technique that will facilitate finding them. Many of these techniques will be used extensively as we progress in our study of algebra. Okay, so there are so many studies um, have been used while finding the value of y-intercept and x-intercept. See, in a given quadratic equation, see, the quadratic equation is fx is equal to ax square plus bx plus c. Okay, so it has been repeated twice, don't consider it. So fx is equal to ax square plus bx plus c. So find the y-intercept by evaluating the function where x is equal to 0. So we have to evaluate the function where, that is y-intercept, where x is equal to 0. So generally what we have to do is, we have to put the value of x in the standard equation, that is ax square plus bx plus c is equal to 0, right? Yeah, okay, up to this only we'll write. Then here x value has been given as 0, so a into 0 whole square plus b into 0 plus c. So you will get 0 plus 0 plus c, so ultimately it is c. So as x value we are taking it as 0, so it has to be 0 and c. So y-intercept is the 0 and c. Okay, so this is how we have to calculate the y-intercept. Next we have yes, so next we have x-intercept, if it is exist, can be found by setting to. Okay, so we have to find out the x-intercept. So how we are going to find out the x-intercept is, so here general solution given by quadratic formula. Okay, so here what we are considering is, the formula of x is equal to minus b plus or minus root b square minus 4ac divided by 2a. You know this, right? So this is the formula, the quadratic formula to find out the x-intercept. Okay, so this has to find the x-intercept we need this. Okay, so you can look at this. We are considering both negative as well as a positive sign, so that we'll get at 2 points of the x-intercept. Okay, so there is a continuation of that. See, using the fact that a parabola is a symmetric, we can determine the vertical line of the symmetry using the x-intercept. To do this, we find x value midway between the x-intercepts by taking an average as follows. So we're going to uh, segregate that based on the sign. Okay, that is plus and negative. Again, in between we are placing plus sign and divided by 2. Okay, so this part will going to cancel, so it will become you have to divide it by again 2 by a, so it will be minus 2b. We have minus b and minus b, it will become minus 2b divided by 2a into 1 by 2. See, this has to be multiply. You have to multiply this, so you will get, so this 2 will get cancelled, you will get minus b by 2a. Okay, so this is the value of x intercept. Okay, so therefore the line of symmetry is the vertical line where x is equal to minus b divided by 2a. We can use the line of symmetry to find the vertex. This line of symmetry can be used to find the value of vertex. See, the four major things we have to find, that is y-intercept, x-intercept, vertex, as well as line of symmetry. Okay, so here in this slide we are discussing about both. So here the line of symmetry is the vertical line where x is equal to minus b divided by 2a. Okay, we can use the line of symmetry to find the vertex. So here we have the line of symmetry as x is equal to minus b divided by 2a. So vertex is minus b by 2a, f into minus b by 2a. Okay, generally 3 points determines the parabola. However, in this section we will find 5 points, so that we can get the better approximate of the graph general shape. Okay, so we are focusing on all this four, like line of symmetry, vertex, y intercept, and x intercept. See, I am taking the example in the next part of this video so that you can understand in a better way how graphically you have to represent it. Okay, so we'll take up the example. So here we have to find see, determine the y-intercept to intercept. Okay, to do this we need set x is equal to 0, find fx. Okay, so here they have given the equation, that is fx is equal to minus x square minus 2x plus 3. So what we have to do is fx is equal to, you just write the equation, x square minus 2x plus 3. Okay, so place here x value they have given it as 0, so that we have to find f0. See, they are asked us to find f0, so that is equal to minus 0 whole square minus 2 into 0 plus 3. See, this 2 will be cancelled, you will get f0 is equal to 3. Okay, so that the y-intercept, so y-intercept is, I'm using the short form, y-intercept is equal to 0. X value we are writing as it is 0 and 3. Okay, this point you have to keep in mind. Okay, what we did is we have substituted value of x in the given equation, so we arrived at y-intercept, that is 0 and 3. Okay, we'll take the next step. The second step is determining the x-intercept, if any. Okay, so as I told you, there is no like every time the chances of finding x-intercepts we so here we are not may not be see, x-intercept is not always been calculated while doing a graphical representation of quadratic function. Okay, if it is there, we're going to do it. That's why they have used if any. Okay, to do this, so what we are setting it, fx is equal to 0 and we are solved for x. Okay, we are using the same equation throughout this steps, that is x square minus 2x plus 3. So here fx they have given 0, so write it this part as 0. So this equation you write it as it is, minus x square minus 2x plus 3. So after this, so what you have to do is to remove this minus sign. So what I'll do is I'll multiply this by minus 1. Okay, so what we will get, 0 is equal to x square plus 2x minus 3. Okay, so after this we have to find a factor for this. For this equation we have to find the factor. You know how to find the factor, right? So 3x square has to be, if you are multiplying you should get 3x square, if you are adding or subtracting you should get 2x. So here it will be x plus 3. I am doing this directly. You can simplify it using a factorization method. Okay, so you'll get x plus 3, x minus 1. Okay, that means x is equal to minus 3 and x is equal to 1. So that means see here we have to consider 0 also, that is fx is equal to 0. Along with that we got two values, minus 3 and 1. Okay, so that means x intercept. So as there is no space, I am just deleting it. Okay, so here x intercept is minus 3, 0 and 1, 0. We got two values for x intercept. Very simple. You have to keep this, whatever the equation they're going to give, first thing what we'll do is we'll going to take the value of x as 0. Secondly, we're going to take the value of fx is equal to 0, and we are finding x intercept and y intercept. Then the next one is we have to find the vertex. How to find the vertex? See, earlier whatever I have quoted, that is all the standard form which will be used to calculate all these four special characteristics. So here we have to use x is equal to minus b by 2a. Okay, so here they have given, so x value of the vertex and then substitute the value in the function to find the corresponding y value. In this example what we have to do is a is equal to minus x and b is equal to a is minus 1. Okay, a is minus 1 and b is equal to minus 2. So that value we have to put. So x is equal to minus b divided by 2a. So as they have given here, so what we are doing is minus of minus 2 divided by 2 into minus 1. So you will get 2 divided by minus 2, that is equal to minus 1. So vertex is equal to minus 1. Okay, this has to be substituted in the equation. Okay, see what we got is, so here we are just taking the correct to find the x value of the vertex and then substitute these values in the function to find the corresponding y value. So we are assuming it as a is equal to minus 1 and b is equal to minus 2. So we got the value of minus 1. So as a vertex, this value has to be substituted in the equation whatever they have given in the sum. So that is we have fx is equal to minus x square, right? Fx is equal to minus x square minus 2x plus 3. Okay, so here fx place we have to take it as minus 1 as we got vertex as, so as we got the value as minus 1. Okay, so minus of minus 1 whole square minus 2 minus 1 plus 3. So we'll get 1 plus 2 plus 3, that is equal to 1 into 1, 1 square is 1 you will get, so this is minus 1. So 2 plus 3 is 5 minus 1 is 4. So here vertex value, so vertex what we got it as, see we have considered it as minus 1 and 4. Okay, so we got it as minus 1 and 4. So next part we have to find out the fourth step, that is what is that, we have to find the line of symmetry. Okay, so here what we are doing it as, we are assuming x is equal to minus 2. That means we are choosing x is equal to minus 2. See here, if we are considering the axis of x and y, okay, so if x is minus 2, so in the equation this will be 3 kf minus 2 is equal to whatever equation we have, that that has to be substituted, that is x minus x square minus 2x plus 3. Okay, so here we are substituting the value of minus 2. Okay, minus of minus 2 whole square minus 2 plus 3. Okay, so you will get minus 4 plus 4 plus 3. Okay, obviously the answer is 3. So first we have considered it as minus 2 and 3. So line of, so the, what is it? Line of symmetry is 2, minus 2 and 3. Okay. So here we got the value of y-intercept, x-intercept, vertex and line of symmetry. So we have to consider all that to plot a graph. Okay. So look at this. See how much value we got for y-intercept, that is 0, 3. X-intercept we got minus 3, 0, 1, 0. This is we got through solving using the factorization method. Okay. Then vertex minus 1, 4 and extra point, that is line of intercept 2, minus 2, 3. Okay. So how to represent graphically is, see, look at it. See, each value has to be plotted in the respective line. So here, see, we have 0 and 3. 0 and 3 will come here. Okay, so that's why we have to mark it, put a dot. Next, minus 3, 0. See, minus 3 we have here, 0 is it will come here. So you have to cross this. Again, we have 1, 0. So here it is 1 and 0. Correspondingly, we have 2 dot. Then minus 1, 4 vertex. See, minus 1 and plus 4. Then minus 2, 3. Minus 2 and 3. So you have to plot a draft. Obviously, it will come like this. No. So this is how it has to be, the graphical representation of the given equation. Okay. So very simple. So we have to find a y-intercept, x-intercept, vertex and extra points to, and after that substituting that values in the plot. Okay. So I just want to explain one more thing here. So here parabola is having a standard form of fx is equal to ax square plus bx plus c. So as per the quadratic equation standard format, this one. Okay. So here, if a is greater than 0, we will going to get open upwards. That means the parabola will be upward facing. If a is less than 0, the parabola will be downward facing, that is opens downward. It will be having its opens in the downward. So this is very important for you. See here what we have assumed, the x value in the beginning, that is minus 1 we have assumed. So it is obviously less than 0. So that's why we got a parabola in the open downwards. Okay. So this is all about the quadratic function and graphical representation of the quadratic function. Hope you can able to understand the concept. See, try to understand the concept. I know it is difficult for you to understand this. Okay. Knowing the concept is very important. I hope you can able to understand this. Thank you.